Okay, so welcome everyone to this webinar, which is brought to you by Help Systems. It's called All Health Broke Loose, and it's going to be an introduction to one of our components in Vityl Capacity Management called Key Performance Indicators. So we're going to provide you the background, what the intent of that component is and how it works, and what the benefits would be from using it. So we'll go through that. So my name is Per Bauer. I'm a Director of Customer Services at the TeamQuest or Capacity Management brand of Help Systems. I've been working for TeamQuest for quite a few years. I'm most of the time, engaged in customer-facing activities, helping our customers to be successful with our solutions, and evangelizing our way of doing capacity management to our to the market, basically. So this is the agenda for today's webinar. We're going to go through the, provide some background as to why we decided to build this component and what the intent of it is. Then we'll give you a primer around how you can use advanced analytics to do optimization. Then we'll talk more in detail about the key performance indicators component, and then we'll also touch on what we believe is a changing operating model that is going to face a lot of us, and how our approach to doing capacity management will be even more helpful under those circumstances. And then at the end, we'll wrap up with a summary and questions. So if you have questions throughout the webinar, you can post them in the chat window, and I'll go through those at the end. And if I don't have time to cover everything, I'll promise we'll get back to you with a more detailed answer later. There will also be a couple of polling questions throughout the webinar. I think there's 2 of them, where we ask you some questions around the content or around your situation based on what we've been talking about, so that we can get an understanding of where you are as an organization, to make the thing a bit more interactive. So without further ado, let's jump into this. So what do we mean by capacity management in the enterprise? If there ever was a time when capacity management was a simple discipline, that's probably not, or that's certainly not true anymore. There's multiple different things you need to keep track of in a modern enterprise in order to successfully manage and optimize your capacity. So you have to have the sort of bottom-up approach or bottom-up perspective. So understand what is the performance of your different components and systems in your data center, or in your cloud subscription, or in your outsourced operation, or whatever that may be. So data about components and the nitty-gritty details about how things are performing. But you also need to have a top-down approach where you focus on the outcome of, or the services that those components underpins. So what is the satisfaction among our customers? What are the transaction volumes that we're processing? Are they as expected, or is there a deviation there? What is the end user experience? What is the quality of our services? Is there any processing delays, or do we keep up with the demand from our customers and users, or do we constantly build a backlog that we need to at some point work off, etc., etc. So with the complexity, with the multi-tier, multi-platform, microservice-based workloads, etc., etc., just looking at system performance and component performance is not enough to assess whether a service is doing okay. So you need to have the top-down approach as well. In order to plan, you need to have an understanding of what is the forecasted scenarios that you need to plan for. So what are the new business initiatives that will create new services or drive demand for existing services? What are the changing priorities? So what is our business plan? What are the things we want to focus on? Where should we put the extra effort into making the experience even better, or coping with increased demand because of new activities in terms of marketing activities or campaigns, etc., etc. So anything that we should, as capacity managers, need to know in order to do our planning. But we also need to review our work with hindsight. We need to look at those forecasts that we did. Were they actually accurate? So how did they compare to the turnout? And when we look at that, is there any correlation across our diverse environment that we aren't aware of, where we can actually, improve things by having a better understanding of that? What is the cause and effect? So what is the impact of changing circumstances, et cetera, et cetera. So all those things. So there's multiple different things that we need to keep track of. It's not performance management in the sense that we just focus on components, but it's not just about planning for the future either. It's a combination of these, and there's data flowing in multiple different directions that we need to keep track of and we need to manage in order to be successful. So we call this the complexity challenge. So what is that? There used to be a time when you could have a more reactive approach to how you did capacity management. So you had a tiger team or a group of people that primarily did manual investigations based on either incidents or based on, a specific technology challenging technology problem that you had. Could be caused by growth, but could also be caused by other impacts to your organization. But what they had in common was that they required the people doing that job to be, very well ingrained into the organization and the environment and the what went on. So you had to have people with a lot of experience and a lot of contextual understanding to understand, what the dependencies were, what to expect in terms of how different workloads would react to an outside event, et cetera, et cetera. And a lot of the work was spent on operative matters like, pulling the data together, making that data, synchronizing that data, making those comparisons or correlations across different silos work, et cetera, et cetera, et cetera. Over time, the complexity has increased. So new technologies have been brought on, started with mainframe, then we moved over to distributed physical systems, over to virtual, over to software-defined data centers, and then now, a lot of public cloud coming in. For each new step in technology or each new technology being introduced, it's not like the old stuff goes away completely. It may fade or become slightly less important, but it's not going away. So over time, we're building a backlog and we're building a legacy. So there's always going to be more and more technologies that we need to mind. Number of components has gone up. We've went from mainframes being a monolithic approach to multi-tier to virtualized environment with VMs. We went over to microservices. We have containers, which is sort of a standard way of deploying those microservices, etc. So the number of components that we need to keep track of have multiplied several times over. The sourcing models, so how we do sourcing and how we operate our environment. Everything used to be on-prem back in the days, and then we went over to co-location where we could rent space in a public data center. We even outsourced some of the operation to a third party, and now you can subscribe to public cloud services as well. So all of these four in combination are used in a lot of organizations. And then the impact of IT on the business. So the importance of IT to, IT has moved closer to the front line of what your business is doing. So business to consumer and business to business has gone through this digitalization movement where more and more services are provided online, and they are more and more sensitive to, poor response times aren't acceptable. It's going to ruin your reputation very quickly, et cetera, et cetera. So there's no way to hide for IT anymore. You're exposed to a lot of customers, and very, by that, shifting demand and behaviors that is harder to forecast and to predict. So all of this has caused you to have to adopt a new operating model. So what used to be a reactive approach has to be proactive. You have to be ahead of the curve. You need to understand before things happen. You went from you had to go from a manual investigation mode to doing more automated analysis. So automatically assess what's going on and provide recommendations based on that. What you used to have, you used to afford to have contextual experts taking care of the investigations. With the volumes and the complexity at hand, you have to have something that is more workload independent. So you need to have algorithms and technologies that allows you to assess risk and health across your systems without really understanding the specific of each workload. So you can't be an expert and you can't understand exactly how each workload is being used. We call it workload agnostic. So basically, it shouldn't matter what type of workload is running on a system. You should be able to assess how that system is doing it regardless. And then, all of these will allow you to, or free up resources and time for you to focus on more strategic matters in the capacity management space. Things like truly understanding what the future demand will look like. So building and socializing the relationship with the business to understand what to plan for, because it doesn't matter how well you do your planning in terms of accuracy if you're not planning for the right scenarios. So making sure that you have top quality data in that sense, but also allowing you to do things like perhaps cost allocation, do a better job around cost allocation, because that's also going to have a big impact on how customers or tenants within your environment will request resources, et cetera, et cetera. So focusing on those strategic initiatives rather than being an operative resource. So this is what we have seen across our customer base and what we see organizations has gone through. So you have to adopt a more proactive and automated approach to how you do your capacity management to survive. So what do we mean by using automated analytics? So optimization using advanced analytics. So basically, advanced analytics is this. So it's a sort of a model for how you do, how you come to, you go from data over to a point where you can make a decision and eventually also take an action. The lower levels here is descriptive and diagnostics. That's basically the performance management side of things. So observing data coming in and hopefully build a sort of a historical trail so you can go back and see what led up to a specific event, but it sort of stops at that. If you want to do predictions based on those types of analytics, it would have to be a fairly simple prediction based on maybe a linear trend at best. The two upper levels is the predictive and prescriptive analytics, and that's where you start to do more what-if based planning. So what if I increase the load, or what if I move this workload, or what if I move this VM off this system? Will that free up resources for me to grow the other workloads, et cetera, et cetera? Or so more based on a specific scenario that you have in front of you. And after that, ultimately you would also like to be able to prescribe a solution to that prediction. So if that happens, if we predict this will happen, what do I need to do to mitigate that, or to what should I do in reaction to that to make it work? Obviously, you want to get as high as possible on this ladder. It requires a new skill set, though, or different skill sets. So it requires more skills to do predictive and prescriptive analytics, of course, and that's why you need software to do it. But the value is also greater. So from an organizational perspective or from a business perspective, you can actually derive more value out of your IT, or IT can play a bigger part in your strategic approach if you do predictive and prescriptive analytics. But also, as an element to this, you need to grow your operational maturity, because as we concluded before, you need to feed your analysis and your analytical algorithms with the right data. And unless you actually adopt certain processes and certain ways of operating, you're not going to be able to find those data points, or you're not going to be able to provide that data. So operational maturity needs to go hand in hand with your efforts in this space, and your efforts to increase your sophistication when it comes to doing analytics. So on the lower levels, as we said, it's sort of the normal way of doing forecasting is doing simple trending. So you take a historical set of historical data showing a certain pattern, and then you analyze what the linear trend is, and then you extrapolate that trend, and that becomes your forecast period. This is a very common way of doing it, and it's in certain areas it may make sense, but it's not generally sort of applicable. The first concern is sort of deciding what metrics that I should go for, because a IT system doesn't consist of one component. It consists of a number of components that needs to be balanced in order to get optimal performance. So how do you weigh those together? Or if you don't do that, which one is your best indicator of performance of the system, which is the one that limits your scalability, and which is the one we need to look at. You need to make that decision first, and there's a possibility for making a mistake there, and in that case, the whole assessment will be flawed. The second one is, what is an acceptable value? So how far can we push a system? What is the maximum value that we can accept for the metric that we picked? And again, that's a manual decision. That's something you'll have to, based on experience or based on your understanding of how that workload is designed, etc. You can come up with that threshold, but it's a manual decision. Third one is, what if we are planning for something new that is not reflected in the historical data? So there is a significant business event that changes the expected growth, and there is no historical data that reflects that type of growth. How do we do that? We can probably twist the curve slightly, but again, it's guesswork, it's a manual process, and it's error prone, and it's subject to mistakes. And then the fourth one, all of these three things we talked about before, is you have to do that. It's takes a meticulous work to do that. You need to focus a lot of attention to doing that, and if you need to do this across hundreds or even thousands of systems, it becomes a scalability issue as well. So you have to have expertise and understanding of all your different workloads, and you need to set those thresholds correctly across all those systems, which is, becomes impossible. So you need to focus your attention to a few vital systems or really important applications and workloads in your environment, rather than doing it across the board. So what we're suggesting instead of doing that is to do using modeling technologies. So capacity modeling, it's basically applying advanced mathematics to a predefined set of metrics. We're taking the empirical monitoring data that we extract from those systems anyway. We put them through our analytical engine, which produces a queuing model. The queuing model is basically a mathematical formula that represents the behavior of that system under stress. So it mimics the system under stress. So if you feed it with increasing amount of transactions, you can observe it and see how much time is spent doing productive work, so service work inside those queues, versus waiting for a queue, or waiting in a queue for something to be available. So you need to keep the balance right there. If you're not queuing at all, you're probably wasting some resources because the system is over-provisioned. But if there is an extensive amount of queuing, you're going to suffer from a performance perspective. So you need to keep that balance right, and that's really what we're observing. This allows us to evaluate the impact of different types of scenarios. So not just growth, it can be something like migration, where you replace the fundamentals of the model with new components that has a slightly different behavior that reflects migration to a different type of platform. Could be reconfiguration. So if you run out of one resource, you add some more of that and scale out, and you'll see what that does to your model, etc. So it's a much more flexible way where you don't have to use your manual, or you don't have to do guessworks in terms of what the impact would be on your scenario of different changes. The good thing about doing this is that it provides a good relative measurement of overall system health. So looking at your current demand, you can easily determine where you are along this response time curve. So that this response time curve allows you to predict nonlinear behaviors. So when you run out of a resource, the response time is going to go up exponentially because you're starved and you have this bottleneck that throttles the whole system from doing what it's supposed to do. And by looking at where you are right now, you can get a good relative measurement of overall system health. You can predict the impact of changing activity. So moving across this x-axis, you can see where your response time ends up and where that puts you. And you can do this across physical systems, of course, but you can also do this on virtual systems. So a hypervisor is also possible to mimic in this. You can also mimic cloud resources. So because it's all compute and it's all storage and it's all IO, etc. So it doesn't really matter what type of environment you're hosting your application in. So this dotted curve that we have in the chart now, that should sort of symbolizes what changes to a system would do. So basically, each time we do a change, whether that change is about adding more resources or removing resources or removing things around your VM so that you free up more resources, etc., we recalculate the model and come up with a new curve. So the curve is unique each time, for an instant in time for a specific application or workload, we create this model which gives us this curve or renders this curve for us. So we do this every time. Every time we do an evaluation, we recalculate everything and provide a unique curve for that scenario. So what are the differences then in summary? So linear trending is focused on resource utilization. So you have to pick the right resource. You have to pick the right threshold for that resource. For capacity modeling, the impact is on actual performance. So what will the response time be based on the scenario that you're suggesting? And it's calculated by sending transactions through a queuing model, and that gives us a much more accurate estimate. Linear trending, you need to maintain those thresholds uniquely, so it becomes a scalability issue, but it also becomes it's also subject to guessing or the expertise of that individual who defines the linear trend and the threshold for that trend. Whereas in capacity modeling, it's completely workload agnostic. It doesn't matter what type of workload it is, because we're looking at how it behaves on a operating system level. So it doesn't matter if it's a database or a middleware or a front-end user UI web server, etc., etc. They behave in the same manner when it comes to queuing. So we can use a fixed scale to assess whether a model is doing okay or not. Linear trending is extrapolation of historical behavior, and if you don't have historical behavior that reflects what you're expecting from the future, it's hard to do it. Whereas capacity modeling captures this non-linear impact of resource constraints. So if you have a scenario that will cause your system to grow exponentially, we'll prevent that, or will predict that, sorry. And then linear trending, you need to focus on individual indicators, whereas the capacity modeling side is an assessment of total throughput and performance, so both compute and I/O activity of the system. So it's a much more comprehensive way of basically, assessing or doing a prediction. So let's pause at that and do a polling question. So I'm going to bring up the polling form here, if I can find it. So on your screen, you should see the question now with a couple of suggested answers, so multiple choice answer. So is increased complexity making your work as a capacity manager more difficult? Has it made it more difficult over time? So please, I'll give you 30 seconds to a minute, not 30 minutes, 30 seconds to a minute to respond to this one. So time is ticking. I'm still collecting responses. For you who haven't responded, please do. I'm not gonna hold you responsible for your answer, so you don't have to think too hard. I think you know the answer probably. Okay, I think we have the answers in by now. At least most of you answered. So we have a resounding majority saying that yes, we have. It is increasing, but we are constantly improving our processes to cope with it. 35%, which is about a third, says that they're struggling to keep up. That may actually be true for the first alternative as well that we mentioned, but at least you're trying. Only 4% of you said that your complexity is not increasing. So I think we can establish that complexity is an issue. Some of you are doing better than the rest to keeping up with it. Okay, thank you for participating in the poll. I'll continue the slides now. So let's move over to key performance indicators. So key performance indicators, as I said, is one of the components of Vityl Capacity Management. We launched Vityl Capacity Management about a year ago, so early in 2018. So it's not a full year. It goes across the whole area of capacity management. So if the traditional sort of divide in capacity management is between performance management and capacity planning, performance management being more the sort of tactical discipline of monitoring your system, analyzing the incoming data, perhaps reporting on that data, and then do some tuning activity based on that data. But first and foremost about real time, so now or historical. I mean, you use the historical data. It's too late to fix the history, but it's, you certainly use the historical data to fix problems that you see here and now, because it gives you a background and hopefully some clues as to what needs to be done from a performance management perspective. The capacity planning side is, focusing on the future. You can do trend analysis, which, as we will come to later, is actually a pretty good method for some technologies or some components in your environment, but for those that have a bit more higher requirements when it comes to the accuracy of the planning, capacity modeling is probably the best choice. So that is future, based on the future. But as we saw before, in order to do those predictions, you need to have a good historical view or an understanding of the historical data. So it's built on empirical data. It's not so one requires the other. You can't do capacity planning without doing performance management or the disciplines of performance management. And also, in order to reduce the amount of performance management that has to be done, you have to do some planning as well. So they feed off each other and they actually complement each other. So our suite of solution, or our suite called Vityl Capacity Management, stretches across all those different disciplines. So we have 4 different components. One called Performance Monitor, which is as the name indicates, the performance data collector and performance analysis. So doing real-time analysis of your data. Key performance indicators that we will spend some time discussing is the tool that sort of sits in between, and then you have capacity plans, which is your workbench for doing forecasts about the future, designing different business scenarios, and then applying that to your IT environment and predict the outcome of different scenarios. And then we have a tool called automated analytics as well that we will come back to in the next slide. So if we look at those top three components, so the key performance indicators, performance monitors, and capacity plans, they play a different role, each of them. So key performance indicators is designed to be this component that brings you awareness. So makes you aware of problems that you need to deal with from either a current performance perspective or from a concern about future capacity. So high level, not too much detail, but clear indicators of what we expect going forward. Performance monitor is where you drill down and do the troubleshooting. So if you find an issue in here and now or there is an indication of current health issues in key performance indicators, you use performance monitor to drill down and look at what the problem consists of and all the details around it, and hopefully come up with a root cause for that problem. Capacity plans is the tool for doing planning, as we said, so growth, migrations, reconfiguration, scale out, etc., etc. So if there is an indicator in key performance indicators that you will run into a capacity problem a few months out, capacity plans is the tool where you find the details around that. You model the same scenario there and find the same details, and then you can drill down and find the exact cause of it, and you can find the solution to it by using the what if scenarios, by adding more resources or reshuffling your resources or moving things around, etc., to accommodate for the scenario. And then we have the automated analytics, which is our solution to create custom content in pretty much all those different areas. It uses the same data, could use the same data sources as the other tools. So anything we do in those could be replicated. We can create custom reports around capacity plans, or we can create different types of analytics that we don't provide out of the box for the other solution. So it's for any type of custom content or bespoke content that you need to provide. A lot of large or organizations with a mature IT have a certain way of doing things, and you want to be able to replicate that in our tool as well. So there's no point for us in just providing out of the box components. That's one thing. We also need to have this, Swiss Army knife type of component that can build any type of specific analytics. It provides a high level of automation and scheduling, so you can automate all those different types of analysis, and then you can schedule it to be published or pushed out to users wherever those users may be. So if we focus then on key performance indicators, key performance indicators is this solution that is designed to provide analyze thousands of systems to identify the few ones that needs attention. So we're applying our queuing theory and our capacity modeling theory, capabilities to all those systems, and to find which ones shows behavior that is needs your attention. It provides simple red, amber, green type of metrics that describes health and risk, indicating where you need to look deeper. We can also aggregate this to provide indicators on group level, because most scenarios nowadays, you're not really interested in a specific system or a specific component. So you group those components into services or applications, or they could be organized by line of business or by customer or tenant, or whatever makes sense for you. And then you can group them together based on that, and then we provide indicators on that group level as well. So how do we define health and risk? So health for us is how a service did perform during the last 24 hours. So focusing on past performance up till the very last minute, how did it behave, or the very last hour, how did it behave, and was there any issues with from a balance perspective, resource balance perspective, or from a pure sort of performance throughput perspective. Risk is how it will perform in the future. So going 6 months into the future, how will this system behave based on the forecasted growth? And that forecasted growth could come from either your historical behavior of your system, so continuing like a organic growth, or it could be a fixed percentage that you provide. So when we calculate health, we take the CPU metrics and we put that through our analytical queuing network models, the way we described. We take memory, we look at memory from a utilization level, but also from a memory management activity level. So if there's paging and thrashing going on the memory side, so not just the utilization, but also activity around managing that memory. IO performance is put through our network queuing models as well. So determining if there is a shortage on IO resources from a throughput perspective. But then we also look at disk space. So we look at current available capacity, of course, and do a sort of a linear extrapolation of that growth on disk space. But we also keep track of historical patterns of behavior. So if there is a cyclical behavior where you fill up a disk during certain days of the week, and then at the end of the week you purge that and start over, or that could be on a daily or an hourly or any type of schedule, we can identify that as well. So to minimize the amount of false negatives or positives, we try to sort of understand the cyclical patterns of disk space as well. And this is then all brought together and combined and normalized to create a single health score. And that health score is what we use to determine the current health of a system. So it's a compound metric covering all those 4 different technologies, and based on our experience from working with customers over the last 20 years, we pretty much know what things you should look for and what are the normal signs of poor performance or poor health of the system. When it comes to risk, we do a similar assessment. So we look at CPU, we put CPU through our network queuing models. We use IO performance in the same way, and we do disk space calculation in the same way. This becomes a combination of linear trending and network queuing models, because disk space is really difficult to model. It's more adequate to use linear trending to assess that. And then we compile or compute a risk score, which is also, according to a fixed scale. So we can rank your systems easily, and then we also predict the number of days to risk. So even if your system is doing okay now, we can say that, is it 30, 60, 70, 90 days till risk? So how far out are they? And then when we present this, we're also going to, sort them by number of days to risk for a system. So this is the way we do it. And if we look inside our solution, how this is then looks and how we present this. So when you go into Vityl capacity management, for some of you this is familiar. For the rest of you, it may be something you haven't seen before, really. So this is the first screen that we enter, sort of. And here you select key performance indicators. When you're coming to key performance indicators, the first screen is going to be a group view where you see systems grouped into different applications or departments or lines of businesses, etc., etc. This can be driven by any type of data source like a CMDB or other service catalogs, so you don't have to set this up manually. So we can synchronize this with a existing data source that allows us to group things in a way that makes sense for you. And then we present the number of unhealthy and at-risk systems for each group. The groups get ordered by severity. So unhealthy is the most or has the highest priority. It trumps at risk. So if there is a current issue, that's always more concerning than something in the future, because it means you have to deal with it immediately, whereas in the future you have some time to deal with it normally. So this is sort of the group view that we present. You then can push the show details for each of these groups, and you'll come into a view that shows the system inside this group. So you have all the systems. They are sorted by order of severity. So number of unhealthy hours is sort of the top priority. So the system that has the system with the most unhealthy hours in the last 24 will end up at the top. And then in a falling order. And then, when we're out of unhealthy systems, we move over to days to risk. So we order them in number of days to risk. So in a healthy system, we show the last 24 hours. Green means that the system were doing okay. Red means that there was an unhealthy or state during that hour. So for this system, there was 2 hours in the evening. Looks like, assuming that we're pulling this report at sort of midnight, where we had some issues with health, and we probably should look into this. For the at-risk systems, we do a projection, as we said, 6 months into the future. So we forecast what's going to happen, assuming a certain growth. What is going to happen to this system? This system has 0 days to risk. So basically the next month, this system will have issues. So it will start to perform badly. It's doing okay right now, but it will run out of resources in the next month and go on like that for 6 months. For some of the other systems, there's, projected at risk is further out. So it's, 100 days. On line 3, it's 100 days till we predict that there will be an issue, and even by then it's yellow, so it's not immediate risk, but it's a condition that we should look into. And then for each system that has an amber or a red condition, we also show what the critical resource is. So the unhealthy system was starved for IO resources, so the IO system couldn't keep up with what the workloads were demanding from it. For the first system at risk, it was a CPU error. On the third row, it's a file system error 3 months out, 4 months out. So different resources, we can highlight which resources it is so where you should start looking from this. And this is where you would then drill down to one of the other tools to get a more, better understanding. The way we do this, if you look at how this is calculated, we calculate health for the last 24 hours. That is evaluated hourly because we realize that, as soon as there is a new data point, we should calculate it. So it keeps updating, rolling hour by hour for the last 24 hours. For risk, which is, 6 months into the future, it makes more sense to do it on a daily basis. So every, normally you would schedule this to run overnight, and then as you get in the morning, you get a new forecast for the six coming months on a daily basis. These are configurable, but this is our suggestion, and it, most of the time this makes sense, and it's sort of a best practice for how to do this. So this is key performance indicators. So high-level indicator of health and risk gives you a very quick understanding of how your systems are doing and where you should spend your time. So based on this, we have the next polling question, which is, do you have processes in place to systematically predict or forecast risk for your critical services? So I've published the polling question now, so you can go in and respond to that. I'll give you a minute to respond again. So the first option is I have a process and it's working very well. Second one is yes, but it's mainly a manual process. And third one is no, I don't forecast it at all. So I'll give it a few seconds more because there's still part of the audience that hasn't responded. Okay, I think I'll close the polling now. So result is that about 50% of you says that you have a process, but it's manually, it's a manual process. So basically you have to do this as a manual exercise, which probably means that you may not be able to do it across everything that you would like it to happen. About 35% of you say you have a process and it's working very well, and then 14% says that no, I don't. So there's a majority not doing this today. So in that case, I suggest that you have a look at how we do it, or you've had a look at how we do it, but perhaps giving us a chance to demonstrate how this could help you in your environment. So the last section of this presentation is another aspect of why we're doing this with key performance indicators. So there's been some updates to how you normally operate an IT organization in recent years as well that causes us to also take a look at what kind of tooling support we provide. One of the big, the reasons for that change is that, and this is just one study from Gartner that shows, highlights the problem. About 70% of IT roles in an IT organizations have no direct contact with the front line, and 94% of the IT staff have a process-centric and siloed mindset in how they do things. So a lot of the people in IT still have a lot of focus on their technology and their minds, there's the silo that they're operating in, and they don't really understand or appreciate the full picture of what they're doing. So in the past, like 10 years ago, probably 10 years ago, most organizations had a siloed approach where tech and app silos were managed separately. There was a PMO function that coordinated large projects across those different silos, but it was a relatively inefficient way of doing things. So many organizations adopted a plan, build, and run approach where they, vertically split those silos, or horizontally split those silos into a plan, build, and run approach where you had, allowed people to specialize at either being the designers or the developers or being the people sourcing or running the different services and applications. This meant that you can go from having a sourcing model that was tied to different technologies and different applications, etc. You can, source them independently. You can, outsource some of your operations. You could look for different alternatives in those different spaces. You also separated the operational and the capital expenditure in a better way by doing this. So this has been adopted by most organizations in the industry. It's not a clean cut, so you don't do either the silo or the plan, build, and run approach, but most organizations sort of approach this plan, build, and run approach. And I think, most of you are probably familiar with that and recognize yourself in that. So what Gartner and others are forecasting, and what we're actually starting to see happening, is that in order to fully, provide support for the future or the next generation of companies where you have digital businesses where you have your product, the product you're providing to the market is basically a digital product, and you need to form product teams inside IT that supports those digital products. So the operating model needs to be more business embedded, basically, and this means that capacity management, among other functions needs to operate on both sides. So they need to be at the front line in those product teams, but it also needs to have you need to have some back office support and some tooling support from a service management layer. But a lot of the capacity management activities needs to happen closer to the product teams or in the product teams. So basically, from a capacity management perspective, you need to have this business embedded capacity management, and that means that forecasting and planning becomes the implicit responsibility of those product line managers or people working out in the product lines. They are less experienced than seasoned capacity managers that could specialize in just doing capacity management. They probably have more strings on their bow than just doing capacity planning. So they need some more and some different type of support from a tooling perspective. So there needs to be an increased focus on agnostic prescriptive advice. You need to out of the box provide agnostic approach that doesn't require them to, or agnostic advice that doesn't require them to be experts in either technology nor the underpinning infrastructure, etc. They don't need to know how the applications are designed in detail, etc. They also need to have more recommendations around what to do. So not just pointing out the problem is probably not enough, because they may not know what to do with that problem. So you need to give them directions on how to deal with it. It needs to be automated because these people have less time for capacity to focus on capacity management. So they basically need to be spoon-fed with prescriptive advice. And there also needs to be an element of self-service, because no matter how good a job you do at designing those tools and solutions for the people out in the front line, they're probably going to look to do some customizations on top of that. So it needs to be self-service. It needs to be easy for them to use and tailor to their own way of working. And that's where we believe that key performance indicators is one of those solutions that could serve that pretty well. So we provide this automation. It automatically calculates this hourly or daily, so risk and health. It's agnostic. It's focused on performance impact, as we talked about before, regardless of workload type. There is a universal indicator of how the system is behaving and how it's doing. We provide prescriptive advice. We can highlight which component that is causing the problem and hone in on where the problem lies. And it has a certain amount of self-service. You can arrange and group components to reflect context. So you can do that within the product line or across product lines. You can, have that level of customization that is required. So we believe that key performance indicators is, could be a tool that not only is used by seasoned capacity management experts, but actually people that are, a bit further from the actual technology and from the core of capacity management, sort of. So to summarize, the increased complexity that we see in IT environments from all different aspects, both from technology aspect and from an application framework perspective, from a business reliance perspective, etc., requires you to update your approach to capacity management. You can't no longer afford to have a reactive and primarily manual approach to it. Our suggestion is to use advanced predictive analytics to assess both current health and future risk. Health and risk is actually the same thing, but it's projected on either here and now or into the future, especially if you're using the right technologies. And we have then, and our suggestion there is then key performance indicators, which gives you, a totally automated solution where you set it up and you fire it off and you schedule it, and then it, gives you this prescriptive advice out of the box. It allows for flexible grouping to provide context, and the indicators are very simple and clear. There's no way you can misunderstand the meaning of them and what you need to do about it. So with that, I'm opening up the floor for questions. I'm going to check what we have received in terms of questions. I have them on a separate screen here, so I will bring that up. Okay, I'll pick a few ones out of the box here. Yeah, this is a good question. So you mentioned CMDB as a potential source for creation of groups, automatic creation of groups. What if you don't have a CMDB that is complete? What are other good sources? Yeah, that is a concern for a lot of organizations, I guess. CMDBs are rarely complete or 100% reliable. The good thing is that we refer to it as a CMDB. Actually, what we're looking for is this service to component mapping. And I would say, based on my experience, that even though CMDB may not be complete in terms of all the configuration items that needs to be in there and all the attributes of those, service catalogs and service dependencies from a component perspective is most of the time there. So we only need a small subset of a CMDB. If you don't have that, even have that in your CMDB, of course, a service catalog of any other kind, you could be a spreadsheet, basically putting different infrastructure components into different services. That's all we need to drive this. So a full CMDB is not really what we're looking for here. See if I can have time for a couple of more questions. Yeah, one more probably. Your risk score has a 6-month planning horizon. Is that configurable? Yes, it is, but our recommendation is not really to do that because, from a best practices perspective, planning more than 6 months out doesn't really make sense, because in most environments, there's too many moving parts, there's too many things going on, there's too many cross dependencies, etc., to make that kind of exercise a waste. So, if you have a 6 months planning horizon, that gives you enough time to react to most things. And if you have provisioning lead times that are longer than 6 months, then it may become problematic, I guess, but that's rare. I mean, I think 6 months is that would be our suggestion, because if you put a longer horizon to it, planning horizon to it, you're probably not going to do anything anyway until it's 3 months until it happens. So it's just going to clog and skew your results by showing risks that are too far into the future to deal with anyway. So I would say the 6 months is probably a good trade-off, or a good balance, strikes the right balance, sort of. I think that's probably what we have time for. So I think our time is up. So again, thank you very much for your attention. Thank you very much for listening in, and thank you for the questions. Those that we didn't have time to answer to, we will follow up with you and get back to you with answers to those. We will publish the presentation as well, so that you can have a look at it again if you want to at your if you want. So with that, thank you very much, and have a great rest of the day, everyone.